It is 03:47 hours on the morning of February 14th, 1944, and the docks at Bordeaux lie shrouded in Atlantic fog so thick that the German sentries can barely see across the quayside to their own feet. A single figure moves through the darkness, a British saboteur whose name will never appear in official records, whose face will never be photographed, whose existence will be denied in official channels for decades to come. Strapped beneath his greatcoat is a small canvas pouch containing something far more lethal than any bomb. Inside are glass vials filled with a seemingly innocuous paste, each one no larger than a fountain pen cartridge. Within 12 hours, the Kriegsmarine destroyer anchored in berth 4 will begin a journey that will take it into the Atlantic, its 4 Admiralty diesel engines consuming fuel that feels subtly thick on the injectors, that burns with minute imperfections in the combustion chambers. Within 48 hours, the first engine will seize. Within 60 hours, all 4 will be scrap metal. Not a single shot will be fired. No explosion will light the sky. The only sound will be the grinding protest of metal on metal as millions of pounds worth of German warship becomes a burning funeral pyre, utterly crippled by something so quiet that the crew would hear it no more than they would hear the autumn wind. This is the story of one of Britain's most carefully guarded wartime secrets: the development and deployment of silent sabotage devices designed not to destroy instantly, but to disable the engines of enemy vessels and vehicles with a patience that was almost diabolical in its cunning. These were not bombs. They made no explosions. They left virtually no trace until failure was already inevitable, and by then the saboteur was already gone, melted back into the shadows of occupied France or the damp fog of a foreign port. The engineers who designed them worked in facilities whose locations were known to only a handful of people. The soldiers and resistance fighters who deployed them risked their lives for weapons whose effects they would never witness. This is the story of how Britain took an obscure industrial poison and transformed it into an instrument of war so subtle that it would reshape the strategies of naval warfare and haunt German high command with nightmares of mysterious failures that seemed to come from nowhere. Between 1939 and 1945, the British Armed Forces and the Special Operations Executive pursued a philosophy of sabotage that was fundamentally different from the crude explosives and incendiary devices favored elsewhere. Whilst American and Soviet strategists favored the dramatic, the visible, the unmistakable destruction wrought by bombs and mines, the British approached sabotage with the mentality of the engineer and the physician. What if, they reasoned, you could cause failure without announcing its arrival? What if an enemy engine could be made to destroy itself through the normal operation of warfare, leaving the crews baffled and afraid? The technology that made this possible had been sitting in industrial warehouses for years before the war began. Abrasive compounds used to polish metals, substances designed to sludge and clog fuel systems, chemicals that would bond to engine components and create friction where there should be none. The innovation was not in inventing something new, but in recognizing that weaponizing the mundane could be far more effective than crafting yet another conventional bomb. The problem was this: by 1943, German naval power in the Atlantic had become increasingly difficult for the Allies to counter through conventional means. Surface raiders had been hunted and destroyed, U-boats were adopting new tactics, but the real vulnerability lay not in combat capability, but in logistics. German warships, particularly the smaller destroyers and fast cruisers that operated as commerce raiders or convoy interceptors, were inherently fragile in their engineering. The Admiralty diesel engines favored by the Kriegsmarine were powerful and efficient, but they were also sensitive to fuel contamination in ways that their British equivalents were not. A grain of sand in the fuel system of a German destroyer would cause catastrophic damage. A chemical compound that mimicked the appearance of perfectly normal fuel whilst degrading the engine from within would be virtually undetectable until failure had already begun. What the British military needed was a method of sabotaging enemy shipping that did not require placing an agent in the path of a destroyer's anti-aircraft guns. that did not require the sophisticated timing mechanisms that limpet mines demanded, and that could be deployed by a single man carrying nothing more conspicuous than a leather tobacco pouch. Between 1941 and 1943, the British had already begun experimenting with engine contaminants under a project codenamed Sludge. Whilst exact details remain classified even now, the fundamental principle has been documented in several memoirs of SOE officers and post-war technical analyses. The compound developed was a thick, viscous paste created by combining finely ground abrasive materials, primarily corundum, the same mineral used in industrial sandpaper, with a specially formulated oil base that would allow the paste to flow through fuel systems without immediately clogging fuel filters. The paste was roughly the consistency of peanut butter, though considerably more granular, and when mixed with diesel fuel in quantities as small as 1% by volume, it would begin a slow process of destruction that few engines could survive for more than a few days of continuous operation. The key to the compound's effectiveness lay in its delayed action. When the contaminated fuel first entered an engine, the abrasive particles would circulate harmlessly through the fuel system, passing through injectors and settling into the finest reaches of the combustion chambers. The engine would run normally. The crew would detect nothing amiss. For the first 12 to 18 hours, the contamination would cause no discernible change in performance. Then, as the quantity of particulate material accumulated in the combustion chambers, the burn characteristics of the fuel would alter. The crew would notice a slight roughness in the engine's operation, a vibration that was not quite normal. By the 24-hour mark, deposits would begin to form on the fuel injectors themselves, narrowing the spray pattern and causing local hotspots in the combustion chamber. By the 48-hour mark, the injectors would be visibly fouled and fuel flow would be severely restricted. By the 72-hour mark, for a diesel engine operating continuously at sea, catastrophic failure would be inevitable. The engine would seize, the piston rods would break, and the entire engine block would become a twisted piece of scrap metal that could not be repaired at sea. The manufacturing of the Sabotage paste took place at a facility near Saffron Walden in Essex, at a location that was officially designated as a facility for industrial polishing compounds and abrasive manufacturing. The compound was produced in small batches, typically no more than 50 kilograms per week, which was then carefully portioned into glass vials designed to hold approximately 10 milliliters each. Each vial was stoppered with wax and sealed with a lead foil wrapper designed to prevent accidental breakage. The entire production process was handled by fewer than a dozen civilians and military personnel, all of whom were sworn to absolute secrecy and who would never be informed of the operational use of their product. The finished vials were then transported in specially designed leather pouches, each pouch capable of holding between 20 and 30 vials, with internal compartments padded with rubber to prevent any sound or movement. A saboteur carrying a full pouch of approximately 25 vials was therefore equipped to contaminate fuel supplies of up to 2,000 liters, roughly equivalent to the fuel capacity of 2 medium-sized cargo vessels or 4 German destroyer fuel bunkers. The deployment of the Sabotage paste began in earnest in late 1943, primarily targeting German shipping in occupied French ports. The SOE's maritime sabotage operatives, typically working through resistance networks in port cities such as Bordeaux, Marseille, and Brest, would identify German warships scheduled to refuel. Once a target had been selected and the security situation assessed, a saboteur would be dispatched to the refueling depot, usually in the hours before dawn. The operation itself took less than 5 minutes. The saboteur would locate the fuel storage tanks serving the German vessel, identify the fuel line leading from tank to ship, and introduce the paste into the system using a simple injection apparatus that resembled nothing so much as an oversized syringe. The injection would be made into a point in the fuel line where refueling operations had already begun, ensuring that the paste would be carried into the German ship's fuel bunkers mixed with genuine diesel fuel. The saboteur would then withdraw, leaving no sign of tampering, no indication that anything unusual had occurred. The results, when reports began filtering back through resistance networks and intelligence channels, were often astonishing. A Kriegsmarine destroyer that had left Bordeaux at dawn with a full complement of fuel and a crew of 230 men would report engine trouble by afternoon. By the following morning, all 4 engines would be offline and the vessel would be taken in tow by a German minesweeper. In one documented case involving the destroyer SMS Friedrich Ecke in March 1944, the contamination was so severe that the vessel limped into Brest under its own power with engine temperatures so elevated that fires broke out in the engine compartment, resulting in the loss of 57 crew members before the fires could be extinguished. The ship itself was subsequently scrapped due to catastrophic engine damage. In another case, a German fuel depot at Saint-Nazaire was successfully contaminated through an underground resistance cell, resulting in the contamination of fuel supplies for an estimated 12 to 15 Kriegsmarine vessels. Of these, 7 suffered major engine failures within 2 weeks. If you are finding this account of silent destruction fascinating, a quick subscription to this channel would help more than you might imagine, as we produce new historical documentaries each week exploring the stranger chapters of wartime innovation and sacrifice. The German Navy was utterly baffled. They had encountered limpet mines before. They understood the threat of explosives placed against hulls. They had procedures for detecting such devices and countermeasures for their removal. But what they could not understand was an enemy that seemed capable of poisoning their ships from within their own fuel supplies, an enemy that left no traces, that made no demands, that announced their presence only through the progressive failure of metal and machinery. German Naval High Command commissioned a series of investigations into what they termed Treibstoff sabotage, fuel sabotage. Ships were ordered to collect fuel samples and have them analyzed. Officers were instructed to watch for signs of contamination. Yet by the time contamination could be detected, it was invariably too late for the engine. The abrasive particles, once they had begun their slow work of attrition, could not be removed or neutralized. The only solution was complete engine overhaul or replacement, a process that could take weeks or months and which the German Navy could increasingly ill afford. The British approach to engine sabotage differed markedly from the German attempts to develop similar weapons. Where the Germans, late in the war, attempted to develop a chemical additive that would cause fuel to gel and clog fuel systems, the British compound was far more subtle in its mechanism. The German approach was essentially a form of chemical attack. It sought to change the properties of the fuel itself. The British approach was mechanical. It sought to introduce physical particles that would damage the engine through abrasion, replicating the effect of sand in the fuel tank but with far greater precision and control. Additionally, the British sabotage paste was designed to be undetectable in the fuel itself. The German chemical additives would alter the appearance or viscosity of the fuel, making contamination obvious to any competent fuel technician. The British paste, when mixed with diesel fuel in the requisite 1% concentration, would create no discernible change in the fuel's appearance or properties. A fuel sample taken from a contaminated tank would show no signs of unusual composition. Only when that fuel was burned in an engine would the damage begin. The American and Soviet equivalents to the British sabotage program were both more crude and more direct. American operatives favored conventional explosives placed against target vessels, using timing mechanisms and chemical detonators. The Soviets similarly favored explosives, particularly magnetic mines deployed by divers against German naval targets in the Baltic and Black Sea. Neither the Americans nor the Soviets developed a silent sabotage compound equivalent to the British paste. This was partly due to different strategic philosophies. The Americans and Soviets favored overt destruction and the psychological impact of spectacular explosions, and partly due to differences in the expertise available. The British had inherited from their industrial past a deep understanding of lubricants, abrasives, and engineering chemistry. This knowledge base, combined with the particular strengths of the SOE in developing unconventional weapons, had created a unique capability. The actual impact of the silent sabotage program on German naval operations remains a matter of historical debate. The German Navy suffered numerous destroyer and cruiser losses between 1943 and 1945, and the causes of many of these losses were never satisfactorily explained. Some historians have suggested that the sabotage program was responsible for the loss of as many as 15 to 20 Kriegsmarine vessels, though this figure remains speculative and based primarily on circumstantial evidence. What is? The innovation of the sabotage paste also influenced the development of later anti-ship weapons and naval warfare doctrine. The concept of degrading enemy capability through the introduction of contamination into fuel or lubricant systems would be revisited during the Cold War, where similar compounds were developed as potential anti-Soviet weapons. The principle that invisible contamination could be more effective than visible destruction became an article of faith in unconventional warfare circles. The Japanese, discovering the British program only late in the war through captured documents and interrogation of prisoners, attempted to develop an equivalent system for use against American shipping in the Pacific, though the war ended before any operational use could be made of these developments. The facility at Saffron Walden continued production of sabotage compounds until the war's end, and for several years afterward the British continued to refine and improve the basic formula. The post-war use of sabotage compounds was largely theoretical. The technology was retained by the intelligence services as a potential weapon against Soviet maritime assets should the Cold War turn hot, but it was never deployed operationally in any documented instance. The formula for the original compound remains classified, though sufficient details have been disclosed in memoirs and technical papers to allow a rough reconstruction of its basic composition. Former SOE officers who participated in the program have, in their final years, released accounts of specific operations, lending credence to the historical record. One of these accounts, documented by an SOE officer codenamed Merlin, describes the successful contamination of the German cruiser Admiral Scheer's fuel supplies in Bordeaux, resulting in the vessel suffering catastrophic engine failure whilst at sea off the coast of Spain in July 1944. The surviving examples of the sabotage paste are today stored in sealed containers at the Defense Science and Technology Laboratory at Porton Down, the same facility that once housed the production of chemical and biological weapons. The vials themselves, photographed but never reproduced, sit in climate-controlled storage alongside other implements of wartime innovation, silent killing devices, unconventional explosives, and weapon systems designed to kill in ways that left no evidence. The facility itself can be visited by appointment, though the sabotage program is rarely discussed in the official tours. The memory of this capability, of Britain's willingness to wage a shadow war fought with invisible poisons and delayed action devices, has largely faded from public consciousness. Yet for a handful of historians and military strategists, the sabotage paste represents something far more significant than merely a wartime innovation. It represents a philosophy of warfare in which the conventional rules are suspended, in which an enemy's confidence in their own machinery becomes an asset to be exploited, in which victory can be achieved not through spectacular explosions, but through the patient, invisible work of degradation and failure. The story of the silent sabotage program is, in the end, a story about the nature of warfare itself. It tells us that victory in modern conflict is not always achieved through the most obvious means. It tells us that the most effective weapons are often those that work without being seen, that announce their presence only through failure and breakdown. It tells us that an enemy's greatest vulnerability may not lie in their weapons or their personnel, but in the mundane infrastructure that keeps those weapons and personnel operational. And it tells us that in the shadow war fought by intelligence services and special operations forces, the most devastating blow may be delivered not by the loudest explosion, but by the quietest introduction of a vial of paste into a fuel line on a dark morning in a foreign port. The saboteurs who carried these vials, whose names have largely been lost to history, understood something that their conventional counterparts often did not, that the enemy you crush with overwhelming force remains an enemy, but the enemy whose equipment fails them mysteriously, gradually, inevitably, becomes afraid. Fear, they understood, was a weapon far more powerful than any explosive ever devised. It was a weapon that required no detonation, no announcement, no dramatic moment of destruction. It required only patience, precision, and the introduction of grain-fine particles into the machinery of war. This was Britain's silent sabotage, and it changed the nature of naval warfare forever.